Hello and welcome to Parallelogram Proof Practice. If you are unsure about proofs and you feel intimidated, you are in the right place. I'm going to go through some proofs from your homework and then a couple from some lessons that we've seen. So this is from your first homework. It was called Properties of Parallelograms. Let's go over this proof together. You always want to read the given and the proof. Where am I starting and where am I supposed to end? Given ABCD is a parallelogram. So we know it's a parallelogram, aka it has opposite sides parallel, and we want to prove one of its properties. We want to prove that angle A is congruent to angle C. Those are our opposite angles. So we want to prove that opposite angles are congruent, which is one of those properties of a parallelogram. All right, so we start with a statement. ABCD is a parallelogram. You should never miss this one on a homework, a quiz, or a test. When the given is written down in the proof, your reason is always given. You don't have to cite anything else. Don't make up a property you've never heard of before. Just write given. Okay, this is new in this unit. It says draw DB. This just comes from our textbook. We're going to go with it. It says draw segment DB. Why am I allowed to draw it? Because through any 2 points, there's exactly one line. And that was one of our basic postulates of geometry that we learned like the third day of school. All right, next thing. AB is parallel to DC and AD is parallel to BC. Well, that is, in a nutshell, the definition of a parallelogram. If you put opposite sides of a parallelogram are parallel, that's fine too. If you say the property or you say definition of parallelogram, you would be fine. All right, now to make this a little bit easier on us, I am going to put some numbers here. I'm going to kind of cheat for simplicity's sake. I have to decide what comes next. What is my next statement? They give me my reason though. My reason is alternate interior angles theorem. And I know that the alternate interior angles theorem says if two lines are parallel, then the alternate interior angles are congruent. So I better say they're congruent, and then my reason will be that theorem. So in my picture, angle 1 would be congruent to angle 2, and angle 3 would be congruent to angle 4. It just depends on how they're numbered. Okay, awesome. Let's mark our picture. Anytime you write a statement in your proof, go and mark your picture. Next, I need to say a statement, and I want my reason to be the reflexive property. And we know that that reflexive property is kind of like shared side. It's when you're saying a segment is congruent to itself. So in this picture, which segment do we think would benefit us that we would want to be congruent to itself? Which segment are both triangles sharing? And it's kind of easy when you look at the triangles. Oh, it's DB. It's that line we drew. So I want to say that DB is congruent to DB. Reflexive property of congruence. Sometimes called the reflexive property of equality. Doesn't matter if you have the word reflexive, you are golden. Alrighty. We need to say something next, and our reason needs to be angle, side, angle. Now wait a minute, we used angle, side, angle when we were proving two triangles guilty of being congruent. So wait, that means our statement is that two triangles are guilty of being congruent. I forgot to put my tick mark for this one right here. All right, I see two triangles. I'm pretty sure they're guilty by angle, side, angle. So now all I have to do is name them. I can start the first one in any order I want. Triangle, I'll do bad, is congruent to triangle DCB. So I said the triangles were congruent. The reason I knew to put that there was because my reason was a congruence theorem. We always start with the given and end with the proof. You always end with the proof. You never get that one wrong because you always end with the proof. Angle A is congruent to angle C. And don't put the reason why is because opposite angles are congruent. That's what we were trying to prove. So why is angle A congruent to angle C? Well, I tell my students, the step after you've proved two triangles guilty of being congruent. If you go past proving them congruent and you want to prove an extra part, a bonus part is congruent, then you use Cpctc, which is corresponding parts of congruent triangles are congruent. Here was the next homework problem from that same homework, the next proof problem, number 21. We are given a parallelogram and we want to prove that opposite sides are congruent. We are just proving these properties one by one. It's awesome. We don't take it for granted, we prove it. All right, what do we start with? The given. We start with parallelogram. A, B, C, D. Given. Done. Cool. All right, well, what do we know about a parallelogram? By definition, a parallelogram has two pairs of opposite parallel sides. So we better say that those opposite sides are parallel. Let's say it. AB is parallel to DC, and AD is parallel to BC. Why? Because that is what a parallelogram is. That is the definition. All right, when we have parallel lines and they are cut by a transversal, let's go ahead and document that we're going to draw a transversal. Let's draw DB. And they gave you a hint. They went ahead and put it up there with a dotted line. Through any 2 points, there's exactly one line. So we needed that segment in our proof. Therefore, we went ahead and documented it. Once again, for simplicity, I am going to number these angles. Less laborious when we are naming them in our proof. All right, so we know the drill. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. That is, of course, the alternate interior angle theorem. Don't forget to mark your picture. If you don't mark your picture, you won't know what evidence you have to prove them guilty of being congruent. All right, kind of like the other one. We're going to use the reflexive property. We are going to say a segment is congruent to itself. So which segment would that be? Definitely DB. There's lots of repetition in these proofs, which is nice. Alrighty, I think we have enough evidence. We've gathered evidence. We can say those triangles are guilty of being congruent by angle, side, angle. Angle, side, angle. So this proof is taking the same route as the other one did. I'm going to name them differently this time. ABD is congruent to CDB. And then it's hard to see that last one. I will have to clear my ink to be able to scroll. But why? What do we end with? Let's see. We always end with the proof. AB is congruent to CD, and the other two sides are congruent as well. Why? Because remember, right after you've said that two triangles are congruent, the next step is usually corresponding parts of congruent triangles are congruent. Now we are looking at your homework from the second night. It was called Proving Quadrilaterals are Parallelograms. We're looking at number 18. We've got another flow chart proof, not a two-column proof. Let's start with, actually not our given. Look at that. Through any 2 points, there's exactly one line. So what do you think we're going to start with? Draw DB, our favorite little segment to draw, our diagonal rather. It is a diagonal. Okay, sometimes people write the given all in one row. Sometimes they split it up and write it separately. So this proof is already telling us we want you to write it separately. So let's just do it. Given, let's write one down. AB is congruent to CD, and AD is congruent to CB. You better mark your picture. They did it for us. Opposite sides are congruent. We want to start, it's like proving the converse. We want to start with opposite sides congruent, then we want to prove that it ends up being a parallelogram and no other shape possible. Okay, reflexive property of congruence. We know this. We've done this in this lesson quite a few times. We want to say DB is congruent to itself. It seems silly, but you have to say it, and that's the reflexive property. Okay, when you write something down, you need to mark it. We just said it's congruent to itself, so it gets tick marks. And now look at that. We have side, side, side. We have tick marks all over the place. So, triangle ABD is congruent to triangle forgot my triangle symbol, CDB. Why are those triangles guilty? Because their sides are congruent. Side, side, side. Tick mark, tick mark, tick mark. Okay, when you go past proving two triangles guilty of being congruent, the reason is Cpctc. But what's our statement? Oh my goodness. So we need to look at what are we trying to get at? I'm trying to say it's a parallelogram. to be able to say that, I need some parallel sides. And one of the ways that we prove parallel sides is that we show, if I can show angle 1 is congruent to angle 2, then I can prove that those segments are parallel. So I need to show that the alternate interior angles are congruent. I'm going to cheat again. I'm going to call it 1 and 2 and 3 and 4. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Why? Because corresponding parts of congruent triangles are congruent. Alrighty, then a lot of people, comes up on a quiz, and some people miss this one. Now that those are congruent, and my picture has gotten quite messy, so I'm going to clean it up a little bit. Now that I know those are congruent, now I can say AB is parallel to DC, and AD is parallel to BC. And why am I allowed to say that? It's not the alternate interior angle theorem. It's the converse of the alternate interior angle theorem. You see, that theorem says, if parallel, then AIA congruent. But we did the backwards. If alternate interior angles are congruent, then we have parallel lines. That's what we did. All right, finally, we need to say something. And the reason is definition of parallelogram. What do we need to say? Well, you always end with the proof. Start with the given and end with the proof. So we're going to say, yay, we made it. ABCD is a parallelogram. And why? Because those opposite sides are parallel. That is the definition of a parallelogram. This is the last one we're going to go over. This was from day 4's lesson. Your teacher might not have had time to get to this proof in the lesson, and so I'm going to go over it on this little proof video. Alrighty, we know the drill. We have BCA is congruent to DCA, and it's given. We're going to mark our picture. BCA, DCA. Given. Check. I marked it. Check. Okay. We are also given that BAC is congruent to DAC. So we're going to document it. Good. We also know that AC is, of course, congruent to AC, and we know that that is the reflexive property of congruence. Cool. Boom, look at that. We've got some congruent triangles. Angle, side, angle. See right here? Angle, side, angle. So we can say, you can name them in any order. All right, so we're going to call it triangle ABC, and that is congruent to triangle ADC. Sure. You have to be careful. You have to look at these arcs so that you know where to start naming it. Alrighty. All right, well, Miss Tanton always says when you go beyond proving two triangles guilty of being congruent, the next step after that, when you want to say that more things are congruent, when you want to add bonus to that, the reason is always Cpctc. What do we want to say past those triangles being congruent? I'm going to get a new color out. Well, we want to say that something is congruent to AD. Well, which one goes with AD? We could even look at our order. AD goes with AB. AD goes with AB. So, AB is congruent to AD by our favorite acronym, Cpctc. Alrighty. It's also saying, oh, put some tick marks there. It's also saying BC is congruent to DC. And the reason is, of course, corresponding parts of congruent triangles are congruent. Look what they're doing over here. They're throwing in another given. This flow chart is kind of crazy, huh? ABCD is a parallelogram. We hadn't said that yet. That is given. So DC is congruent to BA. Ooh, so we have something with a triple tick mark being congruent to something with a double tick mark. So we're tying all four of these sides in together. Look at that. Why are they congruent? Because in a parallelogram, opposite sides are congruent. So we just showed consecutive sides are congruent and opposite sides are congruent. That's going to lead us to all sides are congruent. Look at that. All of the sides are congruent. You don't need to be too concerned about this one. It just means transitive property means that if A is congruent to B and B is congruent to C, then A is congruent to C. Kind of like that, okay? So we made it there. How do we always end? A, B, C, D is a rhombus. And this is where people get it wrong. I saw on the quiz, Cpctc, they just threw something out there because they didn't know what to put. But the answer is actually because the definition of rhombus. By definition, a rhombus is a parallelogram with 4 congruent sides. I just said it had 4 congruent sides. So why is it a rhombus? Definition of rhombus. Okay, I hope you're feeling a wee bit more confident with proofs now. Thank you for watching.